introduction into some more vector stuff. We start with the dot product. So true or false? Yesterday we learned how to add two vectors together. Yes. For those of us who paid attention, we did. No, for those of us who were here. If we have u is equal to a1, b1, and b is equal to a2, b2, then vector u times vector v is referred to as the dot product. And the way that we calculate the dot product is we take a1 times a2 and we add it to b1 times b2. I'm not going to show you exactly why that is the dot product. We don't have time. Generally, I show you where everything comes from, but the it's so weird. So let's just do a very basic example. This is a point that you want to get on the test. It says find the product of the vectors and the angle between them. We don't know how to find the angle between them yet. We do know how to find the product of the vectors. U times v is equal to, we take negative 1 times 2. And we add on to that 2 times 3. What do we get? Negative 2 plus 6 is a couple things there. First of all, that's not difficult to calculate. Second of all, please make sure that you try to show your work, because on the test, a lot of people who think of themselves as very intelligent, and they don't show all the work, and they come up with, instead of 4, they come up with, say, 8. They just write down the number 8, for which I award you 0 points. So at least if I saw some of your work, I could see where your mistake is, and then I could trust that you didn't just guess, and I'll give you a point to your benefit. The angle between the two vectors, suppose we have two vectors that look like this. We'll have vector 1, we'll have vector 2, and we want to be able to find the angle between them. There's a way to calculate that. And the formula is as follows. The cosine of the angle between the two vectors is equal to the dot product, which is u times v, and we divide it by the magnitude of angle u times the magnitude, sorry, not angle u, but vector u, times the magnitude of vector v. Now, let's think about this. If an angle is acute, is it in the first quadrant or second quadrant? First, is cosine positive or negative in the first quadrant? Positive. If an angle is obtuse, is it in the first or second? Second, is cosine positive or negative in the second? Negative. So you can tell that this truly does matter whether it's positive or negative, right? If you get a negative, you're going to get an obtuse angle between 90 and 180. If you get a positive, it's going to be between 0 and 90. So let's apply that to this piece right here. It says find the product and the angles. We set up cosine of theta is equal to, and our formula says u times v, or the dot product. Do I already know that? What is it? Nice job. Hey, buddy. Why not? Now, let's find the magnitude of u. How do I find the magnitude of u? Square root of a squared plus b squared. What is a squared? B squared. Add them together. Square root of 5. You guys are so smart. Did I ever tell you the smartest class I've ever had? What's the magnitude here? Square root of 13. So you get 4 over the root of 65. And for some of you, you don't like that because you don't like the square root at the bottom. But is that my final answer? So go ahead and leave it. Just inverse that to come up with the final answer that you will actually use. So we have cosine inverse of 4 divided by square root 65. Am I working in degrees? Yes. Anything calculate vectors should be in degrees. 60.26. So anything from 7.6 with complex numbers will be in radians. Anything with vectors, 7.7 and 7.8, will be in degrees. Because vectors involves application that we use in our real world, which we really like degrees. But the stuff from 7.6 is really strictly just a mathematical perspective. We really like radians and mathematics. Okay, you try the second one on your own. Find the dot product and find the angle between them. Ready, set, go! Dot product should be -1. Need a different question other than what? So I have 1 times 3 is 3. Yeah. A times A, B times B. Oh, got it. Yep, got to look at this part right here. Good. We brought up a point where people would be making a mistake. That helps us. Okay. I never saw that. Oh, we figured it out. That's good news. Okay. And then the bottom would be the square root of 2 times the square root of times 5. -1 over 5 roots of 2. So I'm going to inverse that on my calculator. Cosine inverse, -1 divided by parentheses. 5 second root of 2, double parentheses. And I get 98.13. Anybody come up with 106? Because you did this. You divided it by 5, and then you attached on that square root of 2. What you just typed in your calculator, what that actually means is -1 over 5 times the root of 2. And that's not what you want. So if you want to include more than one thing in the denominator, use your parentheses. Got it? Clear as mud? Oh, wow. Is that an expression used by other teachers? Did not know that. All right. I think there's a compliment. Awesome. Okay, we move along to orthogonal vectors. Orthogonal vectors are vectors that are perpendicular. You tell me, what does it mean to be perpendicular? 90-degree angles. What is the cosine of 90 degrees? 0. So, if this thing was equal to 0, would the top have to be equal to 0, or would the bottom have to be equal to 0? The top. That means that the dot product of the two vectors would be 0. So very simple to determine if two vectors are perpendicular. Two vectors are perpendicular or orthogonal if their dot product is 0. Determine whether the following vectors are orthogonal. Well, I'll find the dot product. And let me right now show you what some people do on the test. When they do the dot product, they do A times B, and they get -2, 2. You see why? they take negative, or they take 2 times negative 1, they take 1 times 2, and they write it as a new vector. The dot product does not produce a vector. It produces a numerical answer. So therefore, that's incorrect. If you want to do the dot product, you take 2 times negative 1 is negative 2, plus 1 times 2 is 2, which is 0. So the result is 0. So are they orthogonal? Yes. I just realized something. Can I share this with you? You remember something from geometry called the orthocenter? And the orthocenter was when you had a triangle, and I can't remember if it's, I think it is, perpendicular bisectors. So if you have a perpendicular bisector, that means it makes a 90-degree angle, and the result is wherever they all intersect is the orthocenter, orthogonal, perpendicular. Okay, do the next one. Go. Yes, I've thought about being a professor. The reason why I do not want to be a professor is I feel called to be part of the ages of 15 to 18. I think that these are critical years of your life, and not that 18 to 22 is not, or 19 to 22 is not a critical part of your life, but this is an age that I'm ready to work with. When I shared with my professors in college, they said, "What are you going to do someday?" I said, "I'm going to be a high school teacher." They're like, oh. I said, "What?" And they're like, "That scares me to death." I said, "Why?" He said, "You show up and teach people that have to show up every day. Like they don't have a choice." He said, "I teach people who want to show up every day. It's like people pay money to come to my school." And I said, "Okay." And really, what I was thinking in my heart is, "But you're boring. I think high school teachers are fun." I mean, that was kind of my thought. And so you guys will see when you get to college, whatever. Hopefully, you have some great professors. 1 and 3. So, all right. We have A is 5, negative 3. Then we got negative 6 and 10. There we go. So if I want to determine if they're orthogonal, I'll do A times B is equal to negative 30 plus a negative 30, which is negative 60. So no, they are not orthogonal. Do you notice my little trick? When I first look at it, it's like, oh, 5 and 6 and 3 and 10, they probably cancel. No, they don't. So make sure that you work it out, because I tried to trick you there. Did I get anybody? I didn't get anybody? Shoot. Let's cross that off. Let's cross that off, too. Let's do this one later. Since we don't really need to calculate projections, let's cross it off. Why? There were a lot of things I was going to say, but I didn't. I'm glad. That's great. I'm glad I can bring joy. Work is equal to force times direction. One of the chief applications of vectors is being able to calculate work. And you think of work as, I'm working right now, but a great example of this would be the weight room. How much work is accomplished as you are lifting weights. Now, Tanner, have you ever bench pressed in your life? Okay, great. When you are bench pressing, is the force that you are applying to the bar a vertical force or a horizontal force? It is a vertical force. Should there be any horizontal component to your lift on the bench press? If there was a horizontal component, that wouldn't be very good form, would there? Okay, very good. And is it fair to say that the more weight that you are bench pressing, the more work is accomplished? Correct? All right. So um, you can apply these in all sorts of different ways. I'll give you one more example. In the past 2 years, I've moved. Any possible engineers here later on in life? One. Sean Brownlee, your hand should be going up. Anna, engineer? Okay. All right. Find the work done by the force F. So this is my force vector, moving the object from P to Q. So I need my directional vector, my force vector. So W is equal to F times D. Do you think that that's the formula that you should have written down on your notes? Do I give you your notes for this test? How many pages do you get? One, front and back. Can you write examples? You can only write formulas. So work equals force times your direction. So what is my force vector? 1, 1. Direction or distance vector, you could think of it either way, really. We go from 0, 0 to 3, 4, okay? So I want to put that in component form. Remember how I put 2 points in a component form? What do I do the x values? So I get 3, 4. So if you want to calculate the amount of work done, we simply take this vector times this vector. So F times D is equal to 1, 1 times 3, 4. And I get 3 plus 4 is 7. Sweet. No big deal, right? You try the next one on your own. Go. Okay, let's see what you got. So we have the vector 3, negative 2, and we're going to multiply that by the vector negative 1, negative 1. And I get negative 3 plus 2 is negative 1. So work can be negative. For example, if I was pushing the refrigerator up the stairs, but instead of it going up the stairs, it was running me over as it was coming down, then that would be a negative deal. So let's do the lawnmower problem. Let's apply this to the real world so you can see how it works. We have a lawnmower, and it's being pushed. Okay. You're a weird stick figure. I hate you. Oh. All right. Okay. So let's do the problem. So lawnmower is being pushed with a force of 60 pounds along the handle. That makes a 35-degree angle to the ground. So I want you to think about this. If I'm applying 60 pounds of force to the handle, tell me, is the force that I'm exerting horizontally more than 60 or less than 60? Less. Is the amount of force I'm exerting down more than 60 or less than 60? If I wanted to exert exactly 60 pounds of force horizontally and only horizontally, I'd have to be all the way down on the ground, pushing it completely horizontal, and that would be just kind of crazy. If I wanted to have 60 pounds of force vertically, I'd have to be standing on top of it, pushing the stupid lawnmower into the ground because I was mad at it, okay? That's not what's happening, okay? People fired up? We're talking about a lawnmower. What? We don't care about the people in the video. We care about you. If they don't like it, they just turn the sound off anyway, right? We don't care about them. Someday I'm going to make videos where we just teach it wrong, and then we laugh at them afterwards. How'd you like that, buddy? You guys got no chance. All right, so this is 60, all right? It's like you guys all ate a bowl of Grumpy for breakfast or something. I don't know. All right. So we got 60 pounds of force right here. And what I need to do is I want to come up with a formula for work. And work is equal to force times distance. And I got to come up with a formula or some type of representation for the force vector. So I have a force vector that is equal to an A component and a B component, or a horizontal component and a vertical component. You tell me, how do I calculate the horizontal component of a vector? We did yesterday. A is equal to magnitude of V times cosine of theta, and B is equal to the magnitude of V times sine of theta. Awesome. Great. So we've got, what's the magnitude of V? What's the vector force? 60. Boom. Times the cosine of, what's my angle? 35 degrees. And we get 60 times the sine of 35 degrees. Sweet. That's going to give us horizontal and vertical components. That's what I want. Got a nice formula there that I showed you yesterday. Cosine of 35, make sure I'm working in degrees, and I have 49.15. So, as Sean said, it's going to be less than 60 pounds of force that are being exerted horizontally. And it is. It's 49.15. We do the same thing, except we change it to sine. Then we have 34.42. Good. I've got my force vector. Now what I need is, instead of a force vector, I need a distance or directional vector, okay? So let's think about how we're moving this lawnmower. Are we moving the lawnmower vertically or horizontally? Horizontally. How many feet horizontally? 80 feet horizontally. How many feet vertically? 0. Now we multiply. Dot product. And this is no big deal because the 34.42 times 0 just gives us 0. So we have 49.15 times 80. 3,932. And here's how we label it, okay? What is the measurement of our force? We're measuring it in what unit? Pounds. That's all right. It's all right. They said the same thing last hour too. Okay. That's all right. I wasn't. So all right. So and then what is our distance measured in? Feet. So we measure the work done in foot-pounds. That sound familiar to anybody here who's done any mechanic work? Okay. That's how we measure things like torque, right? Except I think it's foot-pound squared. Yep, because it's the derivative. Okay. Nice job. Here we go. The formula. Yep. All right, so you're going to have to do a problem like that on your study guide homework test, okay? So know how to do that. That's a class one. Love the lawnmower problem. Let's try a different one. What's that? Foot-pounds? I would like you to write it, though I probably will not mark it incorrect, okay? But on the AP exam, if they do not list the correct units, without a doubt, it's a point off. All right, a car is on a driveway that is inclined at 12 degrees. 12 degrees. Okay, this one's a little trickier. What does the force represent that we're given in this problem? Okay, so we want a force required to keep from going downhill. Well, what is the current force that we are given? The actual weight of the car, right? Now let's think about weight. Is weight something that we measure at an angle to the ground, or is it perpendicular to the ground? Perpendicular to the ground, right? So it's not perpendicular to the incline, it's perpendicular to the horizontal. Does everybody agree? So the weight imposed by this vehicle is, the force imposed by this vehicle is going to be represented by that vector, which is 3,200. Whoop. Yeah. Well, I got a good story for you after this. Okay, so that's 3,200. Now, I've struggled to find a good way to teach this over the years because honestly, this time of year I get really busy and sometimes I don't even look at the notes before I start teaching this stuff. Actually, usually every day, but this doesn't come up as often. So if I have this triangle, okay, um, which leg, A, B, or C, is generally referred to as the force or the magnitude? Which one? C, right? So this will be our, that hypotenuse or the force part, okay? So we need to draw a triangle that represents horizontal and vertical components. And so in order to do that, I'm going to create a right triangle. And this may not seem very intuitive to you, but you got to trust me. Just kind of do it like this. This is my triangle then. Does everybody see that this triangle has a horizontal component and it also has a vertical component? And then this green part is the magnitude of the vector that we were given, which is 3,200 pounds of force. We agreed that? All right. So what we want to do is we want to be able to come up with the force required to keep it from rolling down the hill. Tell me, which color vector am I wanting to know? The blue. Everybody agreed? All right. Would you like to call that the horizontal component or the vertical component? Thank you. I was hoping you'd say that. You can choose either, but I really think that we should call this the horizontal component. So I'll call that A, and I'll call this B. Well, what last piece of information do I need to find in order to figure this out? I need the angle, right? So I went over this really quickly last hour, but we're just going to do a little bit of geometry. I'm not just going to state the angle. I'm going to actually show you how you could calculate it. Everybody agree that that's 90 degrees? So if this is 12, then this has to be 78, correct? And now this is a right triangle as well, so this angle right in here is going to be 12, and then this angle right there would be 78 degrees, right? So I've got a right triangle, so that was 90, so these two have to add a 90. This makes a 90-degree angle, so 78 and 12, and then I use this other right triangle there, okay? Now, if A is referred to as the horizontal component, is A the horizontal component of 78 or of 12? 78. Okay? A is adjacent to 78. Do you see that? So that's why we have to use that. So we want to say that we want to solve it like this. A is equal to, what's my formula for the horizontal component? Magnitude of the vector times the cosine of theta. So A is equal to, what is the magnitude of the vector? 2,200 times cosine of 78 degrees. Look up my handy-dandy calculator. 3,200 times the cosine of 78. I get 665.32 pounds of force. what would have to be applied to make sure that it doesn't fall back down. That make sense? You like that? You don't care. Somebody wake Sean up. All right. Okay, so tomorrow we did not get to the jet airplane one, so we have to get to this tomorrow. This is a really important problem. But I will also give you your study guide tomorrow as well. Today I have your assignment. Tomorrow it will be a very tiny assignment, okay? Tiny assignment. Because I'm such a nice guy. There you go. I'm going to go try to find my AP people, okay? I think they might be sitting in lunch. I'll be back in a little bit.